Sometimes when you're doing division questions, the quotient comes out really nice. There's no remainder, but that's kind of unrealistic because there's a lot of scenarios I can think of where there are remainders. Like, for example, in my homeroom, I don't have to deal with remainders very often because I have 24 students. I can split them into 6 groups. Every group would have 4 kids, or let's say I'm splitting you into 4 groups. Every group would have 6 kids. That's because there's a lot of factor pairs for 24. But like in Miss Ryan's room, let's say you have 22 students. If I want to take 22 students, split them up into 6 different groups, I mean, some groups are going to have 3 kids, some groups are going to have 4. It's just no perfect match, and that's because there's things called remainders. So let's take a look at an example of a question that would have a remainder. So for example, 64 divided by 5. Now I know this is going to have a remainder right off the bat because 64 does not have a 0 or a 5 in the ones place, and the divisibility rule for 5 is that it does have to have a 0 or a 5. So I know this is not going to come out nice and perfect like the other one. So in this scenario, I'm still going to draw my rectangle. And by the way, this is your number 2 on your sheet. I know that the area is 64, so I'm going to put 64 inside. And 5 is what I'm dividing by, so 5 is my divisor. And so I have my dividend of 64 divided by my divisor 5, and I was trying to figure out my quotient, which is going to be up on top, which typically in the multiplication area model, that would be a factor up there. But like we said before, because they're part of the fact family, factors can become the quotient. So in this scenario, the most important question here is to ask myself, how many groups of 5 can I pull out of 64? Well, I know based on some quick trick, I can try double-digit quick trick because there's double digits here. I can pull out 10 groups of 5 because 20 groups of 5 is too much. That'd be 100. But if I take out 10 groups of 5, that would take care of 50 of the x's. So, for example, like right here in this section, there might be 50 x's because you have a 10 by 5. But obviously, that's not going to take care of all of the x's. That means that there's still 14 left in our area. So I'm going to take that 14 and put it over here into this rectangle and ask myself, well, how many groups of 5 can I pull out of 14? Well, even though it is a double digit, I can't do a double digit quick trick because 5 times 10 is 50, and that's way too high. So I actually am just going to go to my basic facts. I could pull out 1 group of 5 if I wanted to. That would take care of 5 of them, but you want to try and go as close as you possibly can to 14. So I could pull out 2 groups of 5. That would take care of 10 of them. I can't actually pull out 3 groups of 5 because that would be 15. So the best I could do is 2 groups of 5. So if I take 2 groups of 5, that's going to take care of 10 of the x's on the inside of here, and I'd be left with 4. Now, unfortunately, I mean, I could extend this and put a 4 over here, but I can't make a group of 5 with only 4 x's left. So what we call this right here, it has to be lower than my divisor. The remainder will always be lower than the divisor, but because there's 4 left, I am just going to put 4 little boxes here, where each one of these boxes represents 1. So in other words, you're kind of just left over. They don't actually get to fit as nicely into rows and columns. That's because in an array of 64, I can't actually make a true array with 5 rows. And so I can't actually make a great rectangle, perfect, equal rows, equal columns. And so one of my columns will only have 4 in it rather than 5. And that's just because 64 does not have a factor of 5. So right now, my final step in this scenario would be to add my partial quotients together. That is 10 plus the 2. And that equals 12. But obviously 64 divided by 5 does not equal 12 because 60 divided by 5 gives me 12. So that means I have to include the remainder. So we typically use a little lowercase r or capital R here. and you're going to take these 4 right here and make that the remainder. So the answer is 12 with a remainder of 4. So in other words, what you're saying is I could have 12 groups of 5 in a perfect array, but then I would have 4 remaining after that in its own little column, so it doesn't work out perfectly.